Thank you. Okay, so the topic now we'll be covering is about small cell, the concept of small cell, and then integrated access and backhaul. We call it IAB. So release 16, this IAB concept came, and a small cell is because of use of very high frequency. As we know that in case of a high frequency, my coverage would be less. So I'll be creating small cell. But at higher frequency, since I have huge spectrum available, so I can create capacity with very high capacity within a small area. So how these two are interrelated, I'll also talk about that. So let's start with what is the need for a small cell? Why really we need a small cell in a 5G network? The first is that the macro BTS which we have, which is covering a larger area, may not cover all the area. There'll be certain gaps in between. So that is one of the need that you should have a small cell. And then there'll be a patches of uncovered shadow area. So there also you require small cell to cover that particular area. And then in case of a indoor or basement coverage, you may require a smaller cell, indoor or would be covering the indoor or basement environment. And then wherever you need a very ultra high speed or ultra capacity, so there I need to use higher channel bandwidth, which is only available in the millimeter wave, and then we create a small cell. So example is of stadium, that in a stadium when lakhs of people are attending a match, so I require a huge capacity, so I can install multiple number of small cell across the stadium and provide that ultra high capacity. So millimeter wave and a small cell. So as we know that in 5G we support lower band, mid band, and also high band. So 5G supports millimeter wave, and this millimeter wave are part of FR2 frequency range 2, which 3GPP has identified. So for three band, we had seen that three bands in 26 gigahertz, 39 gigahertz, and 40 gigahertz band. Uh, uh, those are millimeter wave identified by 3GPP. And we have a larger channel bandwidth chunk available in these millimeter wave. So there's an abundance in most of the country. So here is the availability of spectrum that also gives a reason why we should use the millimeter wave. And then channel bandwidth use can be more. For example, 3GPP has said that I can go up to 400 megahertz channel bandwidth in FR2, whereas in FR1 I go only up to 100 megahertz. So higher bandwidth can be used. Now, once you have millimeter wave with higher channel bandwidth, that means I can support ultra high speed and the capacity would be bigger. I can support more number of users. And since millimeter wave attenuates fast, so it is useful for a small cell. So if I am deciding to roll it out a small cell to cover those patches or to have ultra capacity, it is wise to use millimeter wave. If I use a lower side of the frequency, in fact, I'm wasting the frequency because I can get a larger coverage with that and I'm creating a lower coverage. So it's a waste. So millimeter wave is the best suited for small cell. But the problem which I may have is the requirement of backhaul. Just consider if I have every 100 meter a small cell, so I need a fiber connectivity reaching to each of these towers. So how this is possible? So that's a challenge. How to solve? There can be many ways. One of the ways is the concept of IAB, which we will talk about. So what are the challenges of backhaul? Challenges is that so 5G NR site, particularly millimeter wave, operating on millimeter wave, would require a backhaul which will run into multi-gigabit per second. If you recall, we had calculated that for 100 megahertz channel bandwidth, although the data speed I'll have 3 Gbps, but my backhaul requirement in various split can go very high. For example, in split 7.2, I need about 25 Gbps of the backhaul, right? So that's the requirement. And in case I'm building a fiber connectivity to each of the site, it will be very, very costly for an operator. And fiber cannot reach anywhere. If you go to, say, Chandni Chowk area in Delhi, there will be many area where digging and laying a fiber would be very, very tough or challenge. And it will take very, very long time even if you decide to do that. Similarly, other availability or other option is the microwave. So microwave may not be suitable because microwave can give you a limited capacity, and also you cannot handle a very, very high bursty traffic which is coming from the small cell. So microwave may not be suitable for small cell millimeter wave kind of environment. And point to multi-point microwave are also having limitation in terms of the data rate. So those can not be used as a backhaul for 5G. Also, even if you can use microwave to some extent, because now in E and V radio, if we have some microwave where I can create a backhaul up to 10 Gbps, but you need to pay for that spectrum. There is a separate cost involved that you have to pay. And that works only in a environment, clean environment, in the sense that if it is raining, if it is cloud, so it will not give you that much speed, right? So only in the clear environment it gives that much speed, and that's an additional cost. So those are challenges IAB can solve. Integrated access and backhaul can solve some of the problem, at least on a temporary basis. So what has happened that as part of release 16, 3GPP has developed a new type of backhaul, which is called IAB, Integrated Access and Backhaul. Why we are saying access? Because the same BTS is being used to service customers, and also it is providing backhaul to the next base station. So this IAB, in many paper we call it 5G self backhaul, that the G node B itself is creating backhaul for the other G node Bs into the network. So this is a very, very a simple picture depicting how it can be used. I think this is taken from 5G America white paper. So if you look at this tower or this base station, so here the fiber is reaching. That means I have a good fiber connectivity at this location. The nearby location BTS says, suppose fiber has not reached yet, right? So what to do? So these BTS, this G node B acts as a backhaul to other two Z node B in the nearby area. And then all the three BTS can operate without needing any separate backhaul, fiber or microwave. The BTS itself is operating as a backhaul. So that's the concept of integrated access and backhaul in 5G. And this is going to solve a lot of backhaul problem, at least initially. Later on, maybe operator can build fiber to these locations also over a period of 2 years, 5 years. But initially, this will be very, very useful. So what are the advantages of IAB and what are the issues a IAB can have? The advantage is that IAB is integrated into the base station. That means I don't need a separate equipment. Once a OEM is supplying a BTS to me, having IAB feature already implemented, it becomes integrated one. I don't need to buy a separate backhaul. Okay, so integrated is the advantage. Second is that deployment can be automated in the sense that nearby BTSs can take the backhaul in an automated way. We can program that way, right? So that becomes, so in case of a microwave, you have to do lot many settings. Then you have to connect one equipment to other equipment. In between, you need router, switches, so many things. So those are kind of reduced. And then deployment becomes faster because of the automation. And it can be either in a star topology, one BTS serving to multiple BTSs in a star topology, or I can have a multi-hop, one BTS giving backhaul to the next BTS and that BTS giving backhaul to the next BTS. So it can be a star or hop topology, both topologies. So these are advantages of an IAB. Uh, uh, Disadvantages is like it is some sort of a temporary 5G deployment, right? Ultimately, you have to bring fiber to all the locations. Uh, then you can migrate to the fiber, right? So easily migrate. You can. The one issue is the sharing of capacity. The meaning here is that the first BTS, which is having fiber connectivity, whatever overall backhaul is available there, that backhaul itself is getting shared among multiple BTSs. So capacity gets shared. So that can be a issue in the sense that if you have less capacity of the first base station, uh, the capacity gets divided. So you'll have less capacity overall. And then there will be impact on latency also. If you have multiple hops, suppose uh, 3 hop scenario, so the latency will increase because of the radio propagation from one BTS to other BTS to the third BTS, in addition to the normal latency, and also there'll be certain processing delay. There'll also be delay related to allocation of resources for backhaul versus allocation of resources for normal user. So in a TDM time allocation fashion, so there will be some delay added. So latency would impact, but for a normal mobile handset use case, this will be really good. Okay, so this is the specification of IAB. So this you can read 38.401, which is like NG RAN specification. So although it will have specifications related to everything of radio access network, and then you'll have a chapter related to IAB. So you can go through and go into detail. There is another document which is called 38.340. This was required to support backhaul environment, because to support backhaul, there is a new protocol added in the overall protocol layers, that is called Backhaul Adoption Protocol, or the BAP protocol or BAP protocol. So this is mainly to support the backhaul. It creates a pipe between the two base station on air. So it's a BAP protocol. So let's look at IAB architecture. This picture is taken from Qualcomm. So basically, as I was saying that 1 बजे के बाद यार कोई भी चीज. So in an IAB architecture, as I said that it can be a star or mesh or combination of that. So this is the donor base station. So fiber backhaul is reaching up to this. So this particular BTS is serving the customers here, right, on a millimeter wave. And it is also creating a backhaul for next base station, which I'm terming as a IAB, integrated access and backhaul. So this BTS is also creating a coverage where user can uh, connect to the 5G network, right? And this IAB is taking backhaul from this particular BTS. Not only that, this IAB itself can give backhaul to say this particular BTS, this particular BTS. So I have this is also working as a backhaul for the next IAB, and this IAB is serving say mobile and fixed wireless in its coverage area. Similarly, you have another IAB which is kind of taking backhaul from uh, from the two base station, one from this, one from this. So two redundant links. It's possible to have redundant link also in case of a IAB. So this is the kind of IAB architecture one can understand. All these scenarios are possible. This picture is from Qualcomm. Okay. So what they're trying to say that the architecture is scalable, that you can have multi-hop and you can have star and mesh topology both. So there is no limit that you have only one backhaul, right? Or number of backhaul which you can have from one G node B. The only limitation is that overall capacity is getting shared. And the network performance, of course, in terms of capacity, in terms of latency. That's the challenge which we'll have. And then the backhaul which is provided. So the backhaul which gets provided between the two base stations is a generic IP backhaul. That means you can send anything. You can send anything. So you can send the backhaul connectivity. You can send any other connectivity. That means you can send like F1 protocol, if you recall, is between DU and CU. So F1 can also be passed on. And suppose you want to do operation maintenance of these IAB, so O&A related data stream can also go. In case you have some other system running at that location, you want to bring some connectivity. For that also this can be used. So please remember, this creates an IP connectivity between these all kind of base stations. So you can use for any purpose other than even the backhaul also. Okay, so let's look at new radio architecture and how IAB is fitting into it. So if you recall, in 5G G node B, there was a monolithic architecture, single box or single product of the G node B as we have in 4G or 3G, where all the radio layers, physical, MAC, RLC, VDCP, RRC, SDAP, all the protocol layers are running inside it. And then it connects to the user equipment on air interface. The other possible architecture in 5G, which was given in the specification, is the split architecture of G node B, where G node B is being divided into two products: control central unit and distributed unit. And you have a standard interface called F1 interface between DU and CU, and the user equipment connects to the base station on N1 interface. So that is the split architecture of 5G as given by 3GPP. If you go slightly more in detail in this picture, so here what you see is that in this disaggregated architecture of G node B, I have CU separate and DU separate, central unit separate, distributed unit separate, and it connects on F1 interface. The important point to note here is that one CU can connect to multiple DU of the 5G G node B. So this is the feature which will be utilized in IAB also, because as I said that one one G node B can become backhaul for multiple base stations. So this is the architecture. In fact, the DU portion will go as a IAB to the next BTS location. In the next BTS is only DU part, and CU is the place where you have the fiber connectivity. Okay. And further, we know that this particular CU is divided into two: control plane CU and user plane CU. Similarly, and then the G node B DU part, F1 protocol also have a F1C and F1U, C for control and U for user plane. So one G node B distributed unit will connect to both the UP part and CP part of central unit for user interface here, user data here, and control data goes here. So this is the architecture of 5G new radio by 3GPP, which will be used by IAB. Okay, so this architecture already available for G node B as per 3GPP are actually used for efficient multi-hop support. So let's look at again overall architecture in a IAB case. So what we do in a split architecture, I have CU and DU. Suppose this is a base station, one base station, where I have central unit and distributed unit, say at one place itself, right? And these two are connected on F1 interface. Now, as I said that I can do multiple DU connectivity with this CU. So I have a multiple DU at other locations. So IAB node, this one and this one, are nothing but a DU, normal distributed unit. Okay. And then this particular DU, which is integrated, is now called IAB donor, because this donor provides connectivity or backhaul to other IAB node. Okay, so this overall is IAB donor. So this is your donor distributed unit. So from here, this is giving you the backhaul on the radio, uh, uh, and you are having. So on that backhaul, all the user data in our UV interface, you may be remembering, will go transparently here, and F1 also will go. F1 is the backhaul coming from that node. So F1. So that means that IP, the tunnel which gets created, will be used for F1 and also for user interface, UU interface. So this particular IAB donor also, IAB node also acts as donor for the next IAB. So using these pipe, basically the F1 and user interface goes on to that particular channel or the backhaul. So that's the architecture of IAB. So, so to conclude, all IAB node and donor DU, all IAB node, this, and the donor IAB will connect to the same donor CU of the G node B, right? So generally, this is the chain which will be creating. One most important point is this one, that the wireless backhaul which we are creating is kind of inside the G node B. So within the G node B, it is all managed in the sense that I don't need to do any separate things. The G node B which I'm procuring, if it is capable of IAB, I don't need anything. It will be kind of a very seamless to utilize that feature. For normal user equipment, for the mobile devices which are in coverage of these IAB nodes, it looks like it is a normal base station. So for UVs, it doesn't impact in the sense that uh, for UV are not required to be changed. All common UVs will be able to connect to the 5G network using this IAB node also. And this architecture is applicable in both cases, whether I have a standalone deployment or I have a non-stand deployment. So in both cases, it works well. So this is the overall architecture of IAB using same NR concept or architecture. So what are different use cases of IAB? One is the backhaul, but what kind of different use cases would be possible once IAB feature is available with us? The first is the indoor coverage. Indoor coverage, like near to the your house, I can put a node, right? I can put a IAB node which gets signal from previous base station, and inside the house it is giving a 5G coverage. So indoor cases can be possible with IAB. Suburban area where you have a gap of coverage. For example, your fiber is reaching up to this BTSS. So I can have a small cell on the electric pole nearby. So here in this you see 3 electric poles. So these electric poles are having IAB node and taking backhaul from this base station. So this kind of environment, so then I can cover this suburban environment in a better way in case I utilize the IAB. In an urban area also, you can have your main base station on top of a tower, on top of a building, and then you can cover street poles, and the backhaul is coming from these main BTSs, where you have a fiber. You may not take fiber to each electric pole. So urban area use case scenario, and then the temporary. If you want to create a coverage temporarily into an area where there is some event is happening, so you can take some sort of vehicle with the IAB node which connects to the nearby base station, and then you have a coverage, venue coverage created for marriage, for parties, for jungle safari, for defense, for army. and you name anything and it can be used. So these are various use cases which is possible using IAB. Uh, Suppose you want to extend the coverage. Suppose you have a fiber, you have a BTS here, and you have a strong signal here. Beyond this, it is weak signal. Spectral efficiency is also low. So what we can do is like right side, you see that at the edge of the coverage, I install IAB node, which creates an access to the next coverage. So you are extending the coverage with IAB node, which you may deploy, and you'll have a higher signal. Then the next use case you can see in this picture, this I have taken from Samsung website. For example, fiber is coming up to this place. And then with this base station, I'm able to cover only this part of the city. But if I have another BTS, which takes a backhaul, when we say backhaul, basically it's a point-to-point connectivity which is being brought. So fiber-like connectivity. So I'm able to have a coverage in this area also. And then this this also acts as a backhaul for the next base station here. So I'm having coverage. So I'm able to extend the coverage with multi-hop solution like this. Then this is another example. This is also from the Samsung website
Sir,
that
sir, I have a question.
yeah.
Sir, who provides the channel now here then to the user?
Who provides?
The channel, sir. Independent channel to the user.
So user, these all donors like, okay, let me tell you that all these donors which you see are having two features. One is the access. That means they are providing coverage to the normal user. In addition, they have a capability to provide backhaul. This donor node, IAB node, is also nothing but a normal distributed unit, and it can transmit normal signal to normal user and backhaul to the next base station. So all these nodes are capable of serving user equipment. Is
Okay,
that
sir. Okay. Yes, sir. Understood. Yes, sir.
okay? So let's look at this particular picture. So in this picture, what is being shown is that you are reaching, your fiber is reaching to one place, say this place. So with this, you cannot create coverage in a street like canyon-like street. So what they do is that on this pole, they are putting a IAB node, and it's taking backhaul from here, and then it is able to cover the entire street canyon, and people are able to use this coverage, right? So this kind of environment or the use cases would be possible. Similarly, suppose you have this base station. So this base station coverage is being obstructed by this a big building coming here. So there is a shadow area here. So what I can do, I can install a new IAB here on this tower. It will take backhaul from this, and then it can provide coverage in the shadow area. So filling the coverage gap can be a use case. Now let's look at environment where I have this side road and I have that side road. So generally this BTS is covering this road. It is not covering this road because of this particular building or whatever obstruction it has. If I have IAV node here, which can take backhaul directly here and then provide coverage in this particular road. So this kind of use case with this, I can suppose it's a like a choraha in a city area, and you have one base station, so you can cover all the four direction using the IAB concept. Now let's go slightly into detail here that how it works. This is also from Samsung website. So this is your donor node. That means you have CU and DU both here, and you are connecting fiber here. So now if you look at the next node, next IAB node, which is distributed unit, come the IAB. So, so the backhaul which is coming, right? For that, either you can use the same antenna or you can have a separate antenna here. connected to this particular antenna, and it is a point-to-point connectivity. Good part is it's a normal mobile termination. So what they're trying to use that the way a mobile signal is kind of using the data channel. So this is using the same feature. So there's no much change required as such, right? So this is called IAB MT or mobile termination, which is using as a backhaul, right? And then this backhaul goes inside this DU. Similarly, the next is also like taking backhaul from this and giving the coverage. So the terminology is IAB MT, mobile termination for the backhaul, and users are able to use coverage of this, and coverage of this, all the three. So basically the IAB mobile termination antenna is either independent set of array or it can be inbuilt into the antenna itself, right? So they can share the same antenna if that works. So that is some sort of virtual IAB MT. If it is common with the access antenna, then we call it VIAB MT, virtual IAB mobile termination. So that's the terminology. Okay, so you can look at this way. So basically, if you have a separate IAB MT, your installation becomes slightly flexible. This can be put at more height or less height, etc., because it has to have a line of sight from the previous base station, whereas this has to provide coverage in a particular direction. So if you have a separate unit, then it's a flexible deployment which you can achieve. So what is this BAP or backhaul adoption protocol which we will have? So basically, if you look at this picture, if you look at this picture, so this shows that you have an IAB donor. That means fiber is reaching up to this place. It has CU and DU both. This is IAB node where I'll have only DU and the IAB empty, which takes backhaul, and then it provides coverage to users also. And the third is again IAB node, which takes backhaul from this and then provides coverage. So in terms of BTS, C it is providing coverage and backhaul. C this is providing a coverage and backhaul, and so on. So my protocol layers are same, MAC layer, RLC layer. These are the same. But I have now, I'm talking about this backhaul. So now I have a backhaul adoption protocol, BAP, and then I'm able to create a tunnel using the backhaul which I'm having. So basically any kind of tunnel, GTP, UDP, IP. So IP you can create and use it for backhaul or for some other purpose. So basically the BAP is enabling efficient IP data forwarding across IAB interconnected radio nodes. So basically it's creating a LAN kind of environment, and then you can configure multiple channel. For example, if you remember 5G quality of service, I need different pipe for PDU session, if you recall, right? So I need different IPsec tunnels. So those can be created for traffic prioritization or quality of service enforcement. So QoS can also be managed in a IAB environment. So that means on this backhaul, uh, am I audible? Am I audible?
It was broken. Now it is.
Yes, sir.
Yes.
So is it okay? Did you understand this picture or should I repeat?
Sir,
First
please
pointer,
repeat
second
the
pointer,
last,
third
last
pointer,
few
which,
sentence.
pardon?
Please repeat the last few sentences.
Okay, so last what I was trying to say, that the pipe which gets created as a backhaul is an IP pipe, and you can pump any IP traffic, either the backhaul part, that is the F1 backhaul, or the user data in addition, you can use this backhaul for quality of service tunnels and also for O&M of these uh, donors. And also you can use, suppose you have third equipment here and you want to manage, those can also be passed on to this particular backhaul. So that means you're getting a normal backhaul environment. Generally, whatever you get in a normal backhaul, you're getting in this backhaul also. So this is again a picture depicting the IAB, architecture, the BAP architecture, backhaul adoption protocol, which has been introduced to support backhaul. So if this is being supported in the G node Bs or the DU units, you'll be able to create backhaul very easily. So basically, so here I'm saying that I'm able to use F1U interface on the same backhaul. So I have a backhaul RLC channel for that.
Windows shift S. అయిపోయింది ఇది ఎట్లా
Madhukar, can you mute? Okay, thank you. Then in other channel, you can pass on control F1C. That is in this particular backhaul RLC channel, you can support F1 control and then so on. So now how data is scheduled. So I have to serve users. I have to also serve as a backhaul. So how scheduling will happen in a TDD environment, time division duplexing, and then I have a concept of scheduling. So how do I schedule? So just look at this picture. Then I'll tell you that how scheduling happens. In this picture, I have IAB donor. That means I have CU and DU, and also DU is a donor DU. And then I'm supporting BAP protocol in addition to RLC and MAC protocol. BAP protocol is for F1 interface, O&M and other. Then I have IAB node 1, which is taking backhaul from this. So I have a DU for backhaul. I have IAB empty, right? So here also I am supporting BAP this side. And since it is also working a backhaul for node 2, so BAP protocol is also extended this side. So I have this IAB empty in the node 2. So DU plus this. So this is kind of two IAB nodes taking backhaul from this particular system. So that means all these three coverages will serve normal user and also the backhaul. So how in a downlink direction, how scheduling happens? So backhaul traffic is scheduled during downlink time slot, right? Downlink time slot, the backhaul. So basically the pipe gets created during that time and then you can use it. So the IAB empty these cannot receive while it's co-located DU is transmitting the signal. So that means when this this particular suppose device is serving user at that time it cannot use the backhaul. At that moment of time it cannot use the backhaul, right? So basically so what you see here is like this like the tilted arrow means this BTS is serving user, right? And this arrow, blue color arrow, horizontal one is like backhaul. Suppose this BTS is taking backhaul data from the previous BTS on a particular moment and also providing backhaul to the next BTS. At that point of time, these users downlink scheduling will not happen. Basically, at that particular moment, that scheduling time, TTI time is given for the backhaul for receiving and providing backhaul to the next. So downlink is blocked. Okay. And here, if you see, it is being transmitted. So when similarly, so there will be multiple phase or multiple time. So every time, either it will serve the user a particular BTS or take backhaul or give backhaul, right? So that's the concept which you use, right? So if you see that phase 1 and 3. Phase 1, 2, and 3. In phase 1, 2, and 3, you are using backhaul transmission. For example, in phase 1, the downlink of this BTS is blocked, but backhaul is on both sides. In this time, this is blocked, but it is providing backhaul to this. And this is blocked because this is taking backhaul, right? In phase 3, this is blocked, downlink side blocked, but it is providing backhaul to this. So this is how. So in this phases, the backhaul is working. In phase 4, it is all downlink transmission. So you can see this, and uplink, it's always uplink transmission is happening at that point. No disturbance is happening. So that means normal downlink operation is blocked for the receiving nodes in all sector during these phases 1 and 3, as you can see in this particular picture. This is a bit complex. If you have not understood, perhaps I can repeat. So the summary is that 5G new radio supports access as well as integrated wireless backhaul. IAB can be deployed using star or a tree backhaul topology or mesh. IAB is scalable and only limited by performance in terms of capacity and latency. And it's a backhaul option for urban, suburban, indoor, temporary sites. Any IP traffic, be it F1 interface, be it O&M of IAB, can pass through this backhaul. And IAB is within the G node B. It's isolated within the G node B. I don't need any separate system. So no impact on 5G core, right? Core is very, very transparent in this case. No processing required in the core. Everything is being done at the G node B level itself. Deployment is faster because of the automation. And then once you have fiber, you can migrate. Instead of using IAB empty, those DU can directly take the fiber from CU to DU. So migration is very fast. So with this, I close the next session also, and maybe we can discuss. So may I request everyone to open your mic video and we can have a small discussion and then we can close it for today. Yeah. So in case we have any question, we can discuss. So these are two small things which I tried completing today. Today's session was by Mr. Prabhat from one of the NIT, but he said that he'll be taking on 25th. So I thought of filling this gap and tried to cover these two topics which was there, but I had not covered earlier, neither covered by other speakers. So it's a bonus topic which we covered today. Any question? Or any discussion?
Sir,
Sir,
I have one question. I joined a little bit late, but how far we keep the separation between normally if we go for a backhaul using OFC, so normally how far we keep from the central stations to the nodes?
So generally these use cases are for nearby base station, and I just said that mostly this will be utilized using the millimeter wave side. So for a millimeter wave, and it uses line of sight for MT for backhaul, right? It's a pointed laser beam kind of environment. Beam forming concept is used. So it can cover up to say 200, 500 meter. It can go even beyond if you have a clear line of sight. And then you can create a small coverage using the millimeter wave of that donor DU or the BTS. So it is for that environment. Suppose one of the use case I said that in an environment you have 4 ways, Chauraha kind of, and then coverage is coming at one side. Put the IAB node and you can create 4 IAB node and 4 direction. You can create a coverage. In a street environment, if you have a BTS at one location, it doesn't cover the entire street. So that can work as a donor BTS, and then I have more poles nearby and it covers the entire the street canyon. So those kind, and suppose indoor coverage. So I can use on top of my house, I have a donor IAB and indoor DUBTS, which can cover an indoor environment kind of a thing. And then it is also used for uh, mobile coverage. So suppose some VIP is visiting an area where I don't have a good coverage. So I can put in a vehicle with IAB node. It takes backhaul from any previous base station, and then it creates a new coverage in the area where function is happening. Even our armed forces can create new coverage in a forward area when they require. So they can have a vehicle which can create newer signal, maybe using private 5G or public 5G network. So there can be many use cases one can think. So there is another use case for public safety. Public safety means suppose there is a fire in one building, one high-rise building. So two things are required. One is the mobile coverage inside the building so that our responders are able to communicate. Second is that I need to locate those responders very precisely. So if I deploy certain mobile IAB nearby, and also I can put an IAB on a drone and I can put nearby that PTSS. So a server can actually triangulate and tell you the exact location of those responders and also those the victims who are like kahan hai. So their location your responders can know and they can help them better. So there are many use cases one can think of using this IAB.
And what about the frequency band? Like, are they using those donors and other, like they are going to use the same spectrum or
Yes,
like?
yes, that's the beauty
Yeah.
that there's no separate spectrum required. Suppose in India, both the operators like Airtel and Jio, they have acquired 1000 megahertz chunk of bandwidth in millimeter wave, 26 gigahertz, right? So they have enough spectrum. 1000 megahertz means a huge spectrum for users. So and we know that I can deploy 400 megahertz channel bandwidth in millimeter wave, right? So if I have deployed 400 megahertz bandwidth, uh, I mean, I have a huge resource, so I can create a backhaul using this spectrum and also serve the users there. And also I have a concept of carrier aggregation. That means I can support multiple 400 megahertz channel. Maybe one of the channel I'm using exclusive for backhaul, another I'm using for the users. That is also a possibility. Or I can mix and match, right? Mix and match, dynamically create those allocations. So I can use the same spectrum.
Thanks.
But it is not for the lower part of the band because lower band have limited channel bandwidth. For example, in the lower side of the band, which is say 700, 900 megahertz, maximum channel bandwidth available is 10 megahertz or 15 megahertz. So I cannot use, so it's a problem even for users. So how to use for backhaul. Similarly, millimeter wave, I have only 100 megahertz, right? Operators are having only 100 megahertz and you can create only 3 Gbps overall capacity. And if you want to give 300, 400 Mbps to the users, it may not be possible to use for the backhaul. So the best use case comes onto the millimeter wave where I have abundance of frequency. Okay, ma'am, you are asking question. I think you didn't ask. So
Yeah, sir,
you forgot
question
to-
is answered.
Okay.
No, one point,
Sure.
sir. So
Okay.
line of sight, you said, is there any skip distance kind of the problems in the this kind of technology?
Problem means?
Uh, so line of sight distance, you said that. Is there
Yeah.
any the collide when you are triangular part you are making? You say that you can identify the exact location kind of thing.
Yes,
So,
yes.
when is there any cross? If two the uh, coverages towers are created on overlapping thing, is there any kind of disturbance or the smooth communication will happen?
Yeah, I think there may be certain interference, but there are mitigation techniques also. So you are right.
Okay.
So there is a possibility,
So
but
that
we
is the
are
scope for
mitigating.
research.
You can always do that. You can always create a network, see what other things can be done. But when they have developed standard, they have taken care to large extent all those problems. But yes, still, if there is some problem, there will always be scope for research in any of these aspects.
Thank you.
Okay, so if there's no more questions, so shall we call it a day for today? One announcement which I wanted to make, that the last day where we wanted to have feedback and valedictory session, although in the timetable we have mentioned 26, but valedictory we want to shift it. Maybe we'll finish our classes on 26, so no more class after Friday, but we will decide one day, maybe in first week of May. On that day, we can have a valedictory session where I can declare or distribute the certificates to all of you through DigiLocker and also physically. And also we will discuss, take your feedback, and do whatever we do in a valedictory session. I'm also planning to invite very senior officials, maybe Secretary Department of Telecommunications, in that valedictory sessions. We are also planning to invite your respective directors of your institute to be part of the valedictory session for say about 30 minutes if they can spare the time. So that's the announcement which I wanted to make, but formally we will convey to you over email and also the WhatsApp group. Okay, so let me say thank you to all of you. So over to you, Madhukar, for closer.
Yes.
Thank you very much, sir.
Thank you.
Yes. Thank you, sir. On behalf of all participants, we express our sincere thanks and gratitude for your excellent presentation on IAB and RedCap in the context of 5G. Your ability to convey complex concepts in such a clear and engaging manner has been USP of your presentation. Your expertise and deep understanding of the subject matter were truly evident throughout your talk. The insight you shared in the session has enriched overall content of the FDP. Moreover, your willingness to address questions and facilitate this discussion further enriched the overall learning experience for everyone in attendance. A special appreciation and thanks to all participants whose active involvement made the session interactive and dynamic. Your contribution added depth to the discussion and enriched the overall learning experience. Once again, our sincere thanks to Shri Ashok Kumar sir and all the participants for making this session hugely successful. Thanks to all. All regards, Jai Hind.
Thank you, everyone. Thank you. Bye for now.
Bye, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you very much.